Today we are going to talk about functions and their graphs. We're starting conceptual unit 9. All right, increasing, decreasing, and constant functions. We say that a function is increasing on an open interval I if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2 for any x sub 1 and x sub 2 in the interval. What? In other words, you can, if you read a graph from left to right, and you trace it, you're rising. That means you're increasing. If you trace your function left to right, this is decreasing because it's coming down. If you trace your function left to right here, it's constant because there's no rise or fall. It's just straight across. Your intervals is what you would say is this interval is increasing from this point to this point. So this would be the interval that it's increasing on, whatever this number was. Let's say that this was -3 and this was +8. Your increasing interval would be from -3, and it would be open, it would be a round bracket because this is not filled in, it's an open circle. And it would go to 8. Again, round bracket because 8 is not included, it's an open circle. Okay, this one, again, let's say that this was at -2 and this was at, I don't know, 10. Okay, so this is decreasing on this x interval, this interval on the x-axis. In other words, this point has a certain y value. This point has a y value that's smaller. This point has a y value that's smaller. The y's are getting smaller, and these, for every x in this interval, the y keeps getting smaller and smaller. So it's decreasing on the interval from -2 to 10. Again, round brackets because those circles are open. Again, pretend that this is, I don't know, -5 and this is 2. This function is constant in the interval from -5 to 2. And again, open circles means round brackets. Okay? All right, so it says to describe increasing, decreasing, and constant function behavior using interval notation. It says use round brackets if the x-coordinate point is not included, open circles. Use square brackets if the x-coordinate point is included, use closed circles. Use the union symbol to describe more than one interval for the same behavior. Okay, so if I was describing this function is decreasing from here to here. This much of the x-axis is decreasing. So it's decreasing at 0, and I'm using a square bracket because that point is filled in. And it goes till 3, and again I'm going to use a square bracket because that point is filled in. This one has two things that's happening. It's decreasing from here to here, and then it starts increasing from here to here. Okay, so I would say the decreasing interval is from here to here, from 0 to 3. And then it's increasing, you know what, but 3, yeah. 3, I don't know, I think that would be a round bracket because at 3, it's going to start increasing. So it's really neither increasing nor decreasing there. It's just the turning point. So it's increasing on 3 to, it stops increasing at 5. And then here, if this is the whole graph, they're trying to break it up. This is actually what you would have seen in the beginning. And so you would have said, well, from here to here is decreasing. So again, decreasing is 0 to 3. Then you would say, from here to here is increasing. So I would say increasing is from 3 to 5. Okay, and then this section, let me do color. This section is constant. So for the constant, I would say that goes from 5 to infinity. Okay. All right. So it says state the intervals on which each given function is increasing, decreasing, or constant. Okay. So this thing, now you got, everybody thinks that, oh, it just would be from here to here. No. This thing is again, now don't get the arrow confused either. It's pointing up. Yes, it's pointing up, but we're reading left to right. So this thing is going to keep going forever and ever and ever, and it's slightly tilted. So all the way from here to right here, because right here it's going to start going increasing. This whole interval, the function is coming down. Okay, so this whole interval is decreasing. So this function is decreasing from negative infinity to 0. And again, 0, yeah, it's included. I'm not really sure what Math Excel is going to do. I don't know if they consider that. Me personally, I don't consider it included because it's not decreasing or increasing there. That's its turning point. So I'm going to go with round bracket, but I could be mistaken. I don't know what Math Excel is going to do. Someone should let me know. Okay, but that's not the only place this thing is decreasing. I need some more room. This thing is decreasing from negative infinity to 0. But from this point, do you see how it starts going down again? So that corresponds to the 2. So I'm going to say it's also decreasing, so union, from 2 to infinity. I know it looks like it's not going to go past 4, but it does. It keeps going to the right as well. And in the middle there, from here to here, which is from here to here, the function is increasing. So it's increasing on the interval from 0 to 2. So it's decreasing from negative infinity to 0, then it increases from 0 to 2, and then it starts decreasing again from 2 to negative infinity. Okay? If we try this one, we've got this interval, which corresponds to this, which is constant. So my constant interval goes from negative infinity to 0. Now look here. See how this point is filled in and this one is open? So this one is going to get a square bracket because it's included in the constant function. Okay, the rest of the function is increasing, which starts at 0 and goes to infinity. But we're not going to include the 0 because it's got an open circle and we go to infinity. And you never use square brackets on infinities. Okay? Alright, so if I look at this one, it looks like we're increasing until right there. Then we're decreasing until right there. And then we're increasing. Yeah? So, if I do this color coordinated, we're increasing here and here. And we are decreasing here. Okay, so if I do doesn't matter what you do first, since I'm still in blue, I'm going to do my decreasing interval. That's from here to here on the x-axis. So it's decreasing from negative 1 to positive 1. Now if I do my increasing, that's from here to here, which is negative infinity to negative 1, union, starting again at 1 and going to positive infinity. Okay? Alright, so you try this one, hit pause, come back when you're ready, and you get from 5 to 12. Okay, they want the decreasing. Well, this is increasing, then it starts decreasing from here to here, which is 5 to 12. Okay, this one they want the constant areas. Hit pause, come back when you're ready. And hopefully you got this. It's constant from here to here and from here to here. Those are the constant ones. That corresponds to all the way to infinity, stopping here. So my constant interval goes from negative infinity to negative 1. Again, see how they're putting round? I don't know. That's filled it. Like I said, it's a turning point. And then it doesn't start going constant again until here, so that would be union from 3 to infinity. Okay? Alright, they want the increasing intervals here. Hit pause, come back when you're ready. And hopefully you got that. Alright, so we're increasing here. And we're increasing here, if you read left to right. So this goes from here to here, and then from here to here. So that's going to go from, oh, sorry, my bad. See that filled in circle? That means it's not continuing, whereas this one's not, so it does continue. So actually my increasing interval is only from here to here. So that's your -2 to 1 union. They put the or, but this one would start at 3 and go to infinity. Okay. Alright, this one wants the decreasing interval. Hit pause. Come back when you're ready. And you get -infinity to 3. Here's where it's decreasing to this point right here. So there's my decreasing interval on the x-axis, which goes from -infinity to +3. Okay, increasing, hit pause, come back when you're ready. And it's increasing starting right here. Now it's coming up, so that goes from here forever, and that starts at 3 and goes to infinity. Alright, definitions of relative maximum and relative minimum. It's very simple. Your high points are relative. It's not the highest point, because this goes on forever. That's why they call it a relative maximum. In other words, it's almost like a local maximum. Even though this thing does things farther out and goes forever and ever and ever, this is a local or a relative maximum, and your low points are your relative minimums. Okay, and we say that, I wish I had numbers here. Let's say that this point was 3, 2, and this point was 7, I don't know, 6. Okay, I would say that we have a maximum. You could say this lots of ways. This would have a maximum of 6 at x equals 7. Okay, it would have a min of 2 at x equals 3. That's one way you could say this. Sometimes they just say that the maximum is 6 and the minimum is 2. When you're actually talking about the max and the min value, you're talking about the y values. Those are the range values. Those are highs and lows. Okay, so again, be careful. They have funny notation. This would be very, very professional, and this would be very, very lazy. And somewhere in between is some answers too. Alright, so it says in the graph of the function is given, if the graph of a function is given, we can often visually locate the number or numbers at which the function has a relative maximum or relative minimum. For example, the graph of f in figure 2.17. This is a sine function. This is the sine function. This is sine x. Okay? So they're counting like they would on a unit circle. They're counting in radians. Okay? So they've graphed this. This would be my relative maximum, and this would be my relative minimum. These would be my x-intercepts, right? All right. So it says, for example, the graph shows that f has a relative maximum at pi over 2. See that language again? Your maximum is at this x-coordinate, but its value is the y-coordinate of 1. It has a relative minimum at negative pi over 2. That x-coordinate gives the lowest y value, which is -1. Okay? Alright, so you do this one, hit pause, come back when you're ready, and hopefully you got A. Okay, this one says, find the numbers, if any, at which f has a relative minimum. These are the relative minimums, the lowest points. It has a relative minimum at -3 and at 3. So you list your x-coordinates, that's where they are at, but the minimum is the y-coordinate, which would be 0, because this ordered pair is -3, 0, this is 3, 0. So you have minimums at this x-coordinate and at this x-coordinate, and that minimum is 0. Okay, this one, they want the maxima and minima. Hit pause, come back when you're ready, and hopefully you got 2. Alright, I've got a maximum right here, which is at 0, 1. I've got a minimum right here, which is at 2, -3. Sometimes they just list the ordered pairs. Okay, this one says, With aging, body fat increases and muscle mass declines. Don't I know it? The line graphs show the percent body fat in adult women and men as they age from 25 to 75 years. Use the graphs to answer the following questions. 1 says, state the intervals on which the graph giving the percent body fat in women is increasing and decreasing. So it looks like we are going up, up, up to right here. So that interval would be from 25 to 55. Women are increasing their fat from 25 to 55. Nice. I'm still getting fatter. Great. Sorry, I'm getting depressed. Decreasing interval, then it starts coming back down. So from 55 to 75, apparently I'll get less fat. I'll let you know. I'm not even 55 yet, so I'm still getting fatter. Golly, this is depressing. Sorry. Oops. Okay, so the next question says, for what age does the percent body fat in women reach a maximum? There's the highest point. Apparently, I'm going to have the most fat when I am 55 years old. So she'll be 55 years old. And what percent body fat is going to be for that age? Read across. What are they counting by? 32, 34, 36. It's going to be 38% body fat. Why would they pick this problem? This is depressing. Use interval notation to give the domain and the range for the graph of the function for women. The domain, just from my data, goes from 25 to 75. My range goes from, my lowest point would be 34 to my highest point would be 38. So 34 to 38 is my range. And it says the function p of x equals negative 0.002x squared plus 0.15x plus 22.86 models percent body fat, p of x, where x is the number of years a person's age exceeds 25. Use the graphs to determine whether this model describes percent body fat in women or in men. Well, it's very simple. You just pick a point and plug it in and see how true it is. Okay, let's pick, I don't know, let's pick this point. Let's pick a point easy to read. Okay, so if I plug in the man's age of 35, I should get 24. If I do, then the model is fitting this. If I don't, I'll check the same point on the women and see if that one works. So if I try p of 35 for the men, that would be negative 0.002 times 35 squared plus 0.15 times 35 plus 22.86. So if we type that in carefully, negative 0.002 parentheses 35 squared parentheses plus 0.15 parentheses 35 parentheses plus 22.86, I get 25.66, which this is at 24. It's pretty close. Let's see about this one. I'm going to pick this point. Now I'm going to pick this point for women because it's easy to read. So I'm going to try p of 25 in my women. I'm using the women's point on the women's graph. Goodness. And we'll see if I get 34. If it's closer to 34, then women win. So if I type that in, negative 0.002 25 squared minus 0.15 times 25 plus 22.86. So negative 0.002 parentheses 25 squared parentheses minus 0.15 parentheses 25 parentheses plus 22.86. I get 17.86. Not even close. I should have gotten around 34, and this would have been way down here, which is way off. So this model models the men's way more better than the women's. Okay? Alright, so how do you determine the intervals for which the function is increasing, decreasing, or constant? Well, you Increasing is rise to right, and then you get the x interval that matches. Okay, that's for increasing. For decreasing, you're looking at places that it falls to the right, and you get the x interval where that is happening. Interval. And for constant, you're looking for horizontal lines and the x interval that happens in. Okay? And then 2 says, suppose that a function f whose graph contains no breaks or gaps on a to c is increasing on a to b, decreasing on b to c, and defined at b. Describe what occurs at x equals b. It's defined at b. I'm assuming that means that b is an x-intercept. Oh, I know what they're saying. It turns around. B is the turning point. Remember how we didn't put square brackets because it's the turning point? Yeah. It's where the function's going to turn around at. Alright, so we are at homework. We are done. Happy homeworking, and I will see you next.